Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is your instructor Anisa Nawaz from Department of Physics, and I am going to teach you the physics of first year. This is our first lecture, after which you would be able to explain the importance of physics in daily life, importance of measurements, physical quantities and international system of units. Ever since man has started to observe and think, he has been wondering about the world around him. Different questions like how is the universe formed? Why is the universe organized the way it is? What is sun? What is moon? Why is there alteration of day and night? How we are able to see the universe around us? These questions arise in his mind, and other questions like why hot coffee will gradually turn cold after an hour, how your image can be formed on the mirror. All these questions are what we attempt to answer in the field of physics. When we are going more and more deep into the physics, then most of the complex phenomena around us can be explained. As physics is the branch of science, which is basically the study of nature, so first we are going to define what is science. Science is facts learned through experiments which are systematically arranged. Facts learned through experiments. So it is not only based on observations, but experiments are essential part of science. Initially, when there was limited knowledge, at that time we were having only one branch, science. But with the passage of time, with the increase in knowledge, science was divided into two branches. First one, biological science, which is related to living things, and second one, physical science, which is related to non-living things. Physics is included in physical sciences. This scientific knowledge was not developed all at once, but it was developed step by step. Like if we are considering our scientific knowledge about solar system, then initially early civilizations believed the earth was covered by a dome. Other planets are moving on that dome, on that shell. Then in the Middle Ages, people thought the sun, stars and planets circle the earth. Both of these concepts were incorrect, and now in the modern world we know that earth and planets orbit the sun. That was step by step development of the scientific knowledge. Galileo was the one of the first persons who used the scientific method of observation and experimentation. Means first he did the observations and then he proved that observation with the help of experiments. Observation and then experimentation. These are the essential parts of science as well as physics. So he was one of the person who laid the groundwork for modern science. Other scientists, they include Newton, Max Planck, Albert Einstein. All these scientists are those which laid the foundation of classical as well as modern physics. Okay, so let's discuss what is physics. Physics may be defined in so many words, but most appropriate and agreed definition is that it is the branch of science which deals with the study of matter, energy and their mutual relationship. Physics comes from the Greek word physikos, which means nature. Okay, so as we have discussed that physics is related to matter and energy. So first discuss what is matter. Matter is basically all those materials that has mass and that takes up space, and energy, the ability to make things change, ability to do the work, ability to make the changes such as temperature, height or speed. And we know that the universe consists of only matter and energy. So everything around us is studied under the branch of physics. Okay. Physics ranges from smallest subatomic particles like electrons, protons, etc. to huge heavenly bodies like galaxies. So basically, physics is the study of each and everything present around us, either it is living thing or non-living thing. Physics is very important in our daily life. Like if we are going to study the planetary motion, construction of steam engines, early construction of radios, cars, television. So these are studied under Newton laws and classical physics, physics before 20th century. And if we are going to deal with microwaves, transistor, computers, internet, lasers, that can be studied under quantum mechanics. And if we are talking about the next great theory, that may include teleportation. Teleportation means that we can transfer mass from one place to another place, just like we can transfer electrical signals from one place to another. That is still not possible, but scientists are working on that, and if they will succeed in this thing, then we human beings may teleport from one place to another place, just like electrical signals. Okay, and another development of this, that if we would be able to travel equal to the speed of light or faster than the speed of light, then our aging process may stop. It means that we will stop growing old, and even that would be possibly the reason for the construction of time machine. We can travel back in time and we can travel ahead of time. That is still not possible, but if we are able to travel faster than speed of light, then this time machine may be constructed. That is also a magic of physics. We are not studying physics like we should study it. Okay, we are just memorizing the concepts, we are memorizing the formula, which is not the true essence of physics. We can also explain everyday phenomena like walking on the basis of physics. Newton's third law is going to explain the phenomena of walking. Listening, production of sound, this can be explained on the basis of physics. Lightning, that is also explained on the basis of electrostatics, which is phenomena related to physics. And most important of all, this online education is blessing of physics. If there was no invention related to physics, then we were not having any internet facility, we were not having any electronic device, so this online education would not be possible. So it is all only due to the blessings of physics. Physics basically can be categorized into two main branches: classical physics and modern physics. Classical physics is the topic which we will discuss in this book. Classical physics is also known as Newtonian physics, and modern physics is based on the concepts of Einstein. So this book is completely related to classical physics. We will not touch modern physics in this book in first year. Okay, so what is classical physics basically? Classical physics is based on what was known before 20th centuries. Means Newton laws, Maxwell's equations, thermodynamics, these are all included in classical physics. And what about modern physics? It deals with the subatomic particles or objects moving near to the speed of light. That was developed after 20th century. Okay, so when we are talking about physics, that is, you can say, quantitative study and qualitative study of the experimental facts. So we can say that physics is an experimental science. It is based on experiments. It is also known as science of measurements. So we can say that without measurements there is nothing, there could be nothing measured. Okay, so come to the first chapter, chapter number 1 in this book, which is measurements. Measurements are very important in the study of physics as well as the study of all the sciences. These are backbone of science as well as daily life. Okay, so how we are going to define measurements? Basically, measurements are comparison of unknown physical quantity with some standard quantity of same rate. comparison of an unknown physical quantity with a known standard quantity is called measurements. What are physical quantities? All those quantities that can be measured or quantified and have some magnitude, these are known as physical quantities. So all those quantities which can be measured are known as physical quantities, which can be divided into two branches, two categories basically. First one, base quantities. Second one, derived quantities. These physical quantities are very important in daily life. For example, if we have to measure length of an object, then we must need some standard of measuring length. That standard can be meter, in terms of which we can measure length, which is a physical quantity. Okay, so we are having physical quantities which are very important for all kinds of measurements, and laws of physics expressed in terms of these quantities. Accuracy is required. Whenever we are requiring accurate measurements, then we need some physical quantities over there. Without that, we cannot develop any law of physics. Without that, we cannot do any calculations. We cannot explain any law. So first category of physical quantities, which is base quantities. These are the minimum number of those physical quantities in terms of which other physical quantities can be defined. Okay, so these physical quantities can neither be derived from one another nor resolve into other quantities. These are called base quantities. For example, length, mass, time, etc. These physical quantities are 7 in number. We will discuss that later. Derived physical quantities. Second category of physical quantities. Those physical quantities whose definition is based on other physical quantities, means that they can be obtained either by multiplying or dividing one base quantity with another base quantity. These are called derived quantities, and these are numerous in number, countless in number. For example, velocity, force, acceleration, etc. Okay, so if we are going to measure a base quantity, then some steps must be followed. First one, the choice of a standard. We must have some standard to measure a base quantity. Like if we have to measure the length, then we should choose a standard that in which you can say what is the standard with which we are comparing the length. Like if we are measuring the length of an object, it could be meter. If we are measuring the distance between two cities, that could be in kilometers. So choice of standard is very important. Second, establishment of procedure for comparing the quantities to be measured with standard. We must have a procedure. We must have some instrument with the help of which we must compare that physical quantity with the help of a standard. Okay, so while we are choosing a standard, then that standard quantity must have two characteristics. First one, it should be accessible, means all the persons, all the people living on this globe must have access to that standard quantity. Like if you are talking about meter, then everyone should know that what is a meter. That should be known to each and every one. If we are talking about time in seconds, so everyone should have same concept of second. Everyone should know that what is second. And second quantity, second characteristic, that it should be invariant. It means that it should not change all over the world. That should remain same in different parts of the world. If we are measuring physical quantity, then we must need some unit of measurement. And how we are going to define that unit? The standard with which physical quantities are compared is called a unit. I repeat, the standard with which physical quantities are compared is called a unit. For example, unit of mass may be gram, kilogram, etc. Unit of time may be second, minute, hour, etc. okay, and so on. Okay, so if we are talking about measurements, then we are having different systems of units that were introduced in different parts of the world. Basically, what is a system of unit? A complete set of units for measurements of all kinds of physical quantities is called a system of unit. So we say that a complete set of base units, derived units and supplementary units for the measurement of all kinds of physical quantities is called system of unit. Different systems of units, they include first one CGS system, second one Fbise system, and third one MKS system. What is CGS system? CGS system, it is the system in which French introduced the unit of length, mass and time. What is the unit of length over here? Unit of length in this system is centimeter. C for centimeter. The unit of mass is gram, G for gram. Unit of time is second, S for second. And derived unit which may be included in this CGS system, that is unit of force which is dyne, and unit of work which is erg. Another system of unit is Fbise system. In this system of unit, the unit of length, force and time are fundamental units. The unit of length in this system is foot. F is used for foot. The unit of force in this system is pound. P is for pound. And the unit of time in this system is also second. The unit of mass in this system is slug, which is a derived unit. MKS system, in this system of unit, British introduced the unit of length, mass and time as fundamental units. Unit of length is meter, M stands for meter. Unit of mass in this system is kilogram, K stands for kilogram, and the unit of time is second, S stands for seconds. Okay, so there was a need that there should be a system of units that should be accepted all over the world. For this purpose, in 1960, International Committee agreed on the set of definitions and standards to describe physical quantities. The developed system is called System International. It is built up of three kinds of units. First one, base units. Second one, supplementary units. And third one, derived units. Okay. So what are base units? These units are related to base quantities. Base units are considered so because they are not derived from any pre-existing number or formula. As we are having 7 base quantities which include length, mass, time, electric current, thermodynamic temperature, amount of substance and luminous intensity. So they are having 7 base units. Okay. So first base quantity is length, whose base unit is meters. It is denoted by small m. Second base physical quantity is mass, which is having unit kilogram, that is also a base unit. Time as physical quantity, which is having base unit second. Electric current, base physical quantity having unit ampere, denoted by A. Thermodynamic temperature having unit Kelvin, denoted by K. Amount of substance having unit moles, denoted by MOL. Luminous intensity, intensity of light basically, that is having unit candela, denoted by CD. Okay, second category of, you can say, units which is included in System International is derived units. SI derived units are units of measurement derived from the 7 base units specified by the International System of Units. Okay, so derived units are those which can be obtained either by multiplying or dividing one base unit with other base unit. Some examples may include Area, formula of area is length multiplied by length. So its unit must include unit of length multiplied by unit of length. That will give you meter square. So area is basically a derived physical quantity which is having a derived unit meter square, as it is obtained by multiplying two base units, so it is a derived unit. Another example may include volume. Volume, formula of volume is length multiplied by length multiplied by length. That will give you length cube. So its formula should be meter cube, another derived quantity. Speed, formula is distance traveled per unit time. So we will divide a unit of distance with the unit of time. That will give you meter per second. Again, division of two base units. So speed or velocity is again a derived physical quantity. Acceleration, having formula speed changed per unit time. So we will divide formula of speed with that of time. Meter per second divided by second. Force, formula of force, mass multiplied by acceleration. F is equal to ma. So we will multiply the unit of mass, kilogram, with the unit of acceleration, which is meter per second square. So kilogram meter per second square, also known as Newton, is another derived unit. Okay. Third category of units is supplementary units. These are those units which are not yet classified as base or derived units. Two geometrical quantities are included over here. First one, radian, which is the unit of plane angle, and second one, steradian, which is the unit of solid angle. We will discuss these supplementary units in the next lecture, inshallah. Okay, so I would like to end my lecture with the quote of Isaac Newton, that truth is ever to be found in simplicity and not in the multiplicity and confusion of things. It means that you should clear your concept instead of memorizing a lot of things, a lot of formula. Just clear your concept. That would be simple and you will find the truth. Okay. Thank you so much. That was all for today's lecture.